Welcome to InfoStream YouTube channel. In this video, let's discuss about the checksum in computer networks. So this is the part 2 video. Part 1 video link will be given in description. You can see it there. So this is a error detection method. So when a sender sends a message, so let us consider you as a sender. You are sending a WhatsApp message or a Gmail to your friend. So your friend will become the receiver. So you are the sender of that message and your friend is the receiver of that message. What this checksum will do is, it will check whether any error has occurred when you send a message and it is received at the receiver side. That is, any error is there or not, it will be checked by the checksum when you send a message from sender to receiver. So now, how to solve the problem is, here in the question there will be given set of segments or frames. Here if you see, I am having 1, 2, 3, 4. 4 number of frames, or you can call them as segment. So let us call it as n. n equal to 4. Now in each segment or in each frame we will be having same number of bits. Here we are having 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits. Here also 8 bits, 8 bits, 8 bits. So I can write m value will be equal to 8. 8 means number of bits in a frame. And n means how many number of frames are there in the given question. So how to solve this problem means, here as the heading only tells, check the sum. Checksum means check the sum. So the first step is add all the segments. So here we are having 4 segments or 4 frames. First let's add them. So first we will be adding 2 in a batch. So this is the first batch. So this is the first one. This is the second one, that is 2 segments I will add. 1 0 1 1 0 0 1 1. Next 1 0 1 0 1 0 1 1. Now how to add these segments means, we know that 0 plus 1 will be equal to 1. 1 plus 0 will be equal to 1. Next 1 plus 1 will be equal to 2. But you can't write 2 in zeros and ones. So how to convert it to zeros and ones means, here using the 2 powers, 2 power 0, 2 power 1, 2 power 2, 2 power 3. So what is the value of 2 power 0? Whatever the value or the number having 0 as its power, its value will be equal to 1. Whether it may be 16 power 0, whether it may be 100 power 0, its value will be equal to 1. Next 2 power 1 will be 2. 2 power 2 will be 4, 2 power 3 will be 8. Now if you see here, I need 1 plus 1, that is 2. So I need 2 and I don't need all others. So I put 1 for 2. So we know that whatever the value we will be counting will be starting from the non-zero digit. So if I write here 0, 1, 0, what you will tell? This is 10 rupees. That is, you will be starting the count from the non-zero element. So how many number of zeros before the non-zero element, you will not consider it. For example, 0, 0, 0, 0, 1, 0, 0. What you will tell? It is equal to 100 rupees, like that. So the number which are, so we will start the counting from the non-zero element, and zeros after the non-zero elements are counted, but the zeros before the non-zero element is not considered. So now if you see here, 1 is the non-zero element. After that 0 can be considered. So 1 and 0. 1 and 0 for 2. Now if I want to write for 3. So if I want to write for 3, I need 1 also. 2 plus 1 will be 3. So I put 1 for 1 also. So the condition will be 1 plus 1 plus 1, and you can write it as 1 and 1. So these are the 4 conditions or the 4 simple tricks you can use to solve the problem related to checksum. So 0 plus 1 will be 1, 1 plus 0 will be 1, 1 plus 1 will be 2. So how will you write it? 0 will be the sum and 1 will be the carry. 1 plus 1 plus 1, 3. How will you represent it? 1 will be the sum, 1 will be the carry. So now let's solve here. 1 plus 1 will be 2. So we will write 2, 0 will be the sum and 1 will be the carry. 1 plus 1, that is 3. How will you represent 3? 1 will be the sum and 1 will be the carry. 1 plus 0, it will be 1. 0 plus 1, it will be 1. 1 plus 0 is 1. 1 plus 1 will be 2. So I will represent 2. 0 will be the sum, 1 will be the carry. 1 plus 0 plus 0, it will be 1. 1 plus 1 will be 2. How will represent 2? 0 will be the sum and 1 will be the carry. Now if you see the second step, if you got the carry equal to 1 at the ending, what you will be doing? You will be adding it to the LSB. What is LSB? LSB means least significant bit. So the first element from the right hand side towards the left hand side will be the least significant bit. So I will be adding 1 to that. So 0 plus 1 will be 1. Now no carry has been forwarded to the next element. So you can directly copy all the elements from the previous step. Now first two segments are over. Now let's add the third segment. What is the third segment? 0, 1, 0, 1, 1, 0, 1, 0. Now if I add this one. Now if I add this one, what will be the value? 1 plus 0, it will be 1. 1 plus 1 will be 2. How will write 2? 0 will be the sum and 1 will be the carry. 1 plus 1, it will be 2. 2 plus 0, it will be 2 itself. I will represent it 0, 1 carry. 1 plus 1 plus 1, 3. 1 will be the sum, 1 will be the carry. 1, 2, 3. So 1 will be sum, 1 will be carry. 1, 0, 0. That is 1 only. 1 plus 1 will be 2. I will write 2. 0 will be the sum and 1 will be the carry. 1 plus 0 plus 0, it will be 1. So no carry has been forwarded for the next step. So you will start adding the fourth segment to the sum you got. So what is the fourth segment? 1, 1, 0, 1, 0, 1, 0, 1. So now if you add this one, what will be the value? 1 plus 1 will be 2. How will you write 2? 0 will be the sum and 1 will be the carry. 1 plus 0 plus 0, it will be 1. 0 plus 1 will be 1. 1 plus 0 will be 1. 1 plus 1 will be 2. How we will be writing 2? 0 will be the sum and 1 will be the carry. 1 plus 1 will be 2. 2 plus 0 will be 2 itself. 0 is the sum, 1 is the carry. 1 plus 1 will be 2. 0 is the sum, 1 will be carry. 1 plus 1 plus 1, that is 3. So 1 will be the sum and 1 will be the carry. When you are left out with 1 as the carry, you will be adding it to the least significant bit. So I will add it to the least significant bit. So what will be the value? 0 plus 1 will be 1. No carry has been forwarded to the next step. So what we will be doing? We will be just copying the elements from the previous step. So now you got the remainder. So we will be calling this as remainder. Now what you must do is, whatever you wrote in the sender side, just copy it to the receiver side also. The simple trick in the every checksum problem is, what you wrote in the sender side, just you copy to the receiver side also. So now we just copied whatever we wrote in the sender side towards the receiver side. Now whatever the process I will write here will be the continuation at the receiver side. So the same reminder we got in the same both the sides, that is in the sender and the receiver. So now at the sender side there will be a checking whether the sender side SMS or the message is correct or not, which is received at the receiver side. How means? First it will take the reminder. First it will take the reminder. In both sender and receiver side same reminder is there, and it will add the checksum to that reminder. Checksum. So we know the value of the reminder. What is the value of the reminder? 1 0 0 0 1 1 1 1. But we don't know the value of the checksum. What is the checksum means? It is the reciprocate or complement of the reminder. That is 0 will become 1, 1 will become 0 plus 0 will become 1 and 1 will become 0. Now if you add 1 plus 0 will be 1, 1 plus 0 will be 1, 1, 1, 0 plus 1 will be 1, 1, 1, 1. So you got the sum equal to 1. Now at the last step you will be complementing. We will be complementing the answer you got when you add the reminder and the checksum. So what will be? It will be equal to 0 will become 1, 1 will become 0. So all 1s are there, all 1 will become 0. So if you see here, at the receiver side, at last we got all the values equal to 0. So you can conclude that. So now we wrote accepted. So you can directly conclude that the message you sent from the sender side is correctly received at the receiver side without any error being detected using the checksum. When you get the 0 as the value at the receiver side, when you add reminder with checksum and complement its sum, when it will be equal to 0, you can write it as accepted and you can conclude the sender side message has been received at the receiver side without any error. So the message is accepted at the receiver side. So hope you understood the topic, how to solve the checksum related problem. So the more problems you solve, the more concepts you get, or you will be strong in that concept. So the more video links has been given in the description through the playlist. You can see it there. If you liked the video, please subscribe and support us. And if you have any doubt regarding this topic, please do comment below. I will clarify it. Thank you.